In this video, we're going to talk about a very important point about plasma devices, is their operational frequency. Now, first of all, we're going to try and explain what frequency is. At the output of any plasma device, vast majority of plasma devices, what you'll find if you use an oscilloscope, you'll find a sine wave of the sort, or something that looks very, very similar. What manufacturers are trying to achieve is always a sine wave. So, what frequency is defined by the period. The period is the distance in time between one peak and the next. And that applies to any waveform that is periodic. So, not only the sine wave, any periodic waveform. But this is not that important in this particular video. This is a bit too much theory. But what frequency is 1 divided by the period. So if, say for example, the distance in time between that peak and that peak is exactly 1 second, 1 divided by 1 is 1 hertz. So you have, this is the normal definition of frequency. What we find in most devices is that this frequency is fixed, and that applies to most devices, including the most expensive ones. And at Areton, what we have done is invested in order to give you a variable frequency, which is something new in the market. And as we'll see in this video, this has got its advantages. Now, let's start to understand also the physics about the frequency and how it works in plasma in this type of devices. First of all, you may be familiar with the frequency of the mains, which is between 50 and 60 kilohertz. 50 hertz in Europe, 60 kilohertz in the United States. Depending on what country you go, this is either 60 or 50 hertz for a number of reasons. Now, what happens if you touch or you get in contact with this type of frequency is that you get an electric shock. What the electric shock is really is an electromuscular stimulation, and is so intense that it can cause cardiac arrest, so it can cause death. Therefore, this type of frequency is dangerous to the human body, even at relatively low voltages, i.e. the voltage that we've got in the mains in our houses. So if you touched the plug, whatever is in the plug sockets, then you'd get a shock, and potentially it could actually kill you. However, this doesn't happen any longer. It's very hard to happen because we've got other devices that protect us. So in case we even touched it, it's going to be quite difficult to be injured seriously. So the main important concept to take away here is that at these low frequencies, 50 to 60 hertz, we have an electromuscular stimulation. So basically our muscles start to tense up, and also the electricity passes through our bodies inside our internal organs. And this is why our bodies heat up if you've got this sort of, if you touch this sort of currents at these sort of frequencies. However, if you touch the mains, the main danger is going to be the electromuscular stimulation, which is caused by this very low frequency. And also you're going to get a degree of heat up in your body. But if you're going to be injured, basically you're going to be injured by the electromuscular stimulation, which can cause, as I said, cardiac arrest. But the voltage is too low for having an intense heat up of the internal organs. So what happens is you can actually die of heat up of the internal organs if you touch voltages at these frequencies, which are in the region of kilovolts. And if you touch those without any protection, then and the current goes through your body from the mains through your body into earth, then you could potentially die not of cardiac arrest, but mainly from the heat that your body is going to feel to develop inside, because the current passes through the internal bodies, your internal organs, and therefore it causes a lot of damage that way mainly. So how does these devices work then? So actually they do develop very high voltages, but they don't harm us. So we can actually get an electrical arc on our skin, on our eyelids, but that doesn't really harm us. So how is that possible? So how is it possible that if we touch the mains in our houses, we get a shock? If we touch the electrical cables at kilovolts, which is what we've got in this sort of devices, then we're very likely to die. Whereas, and also if we get an electrical arc from the sort of energy sources at these frequencies, then we're very likely to be injured. So why are we not injured when we have when we're actually subjected to the electrical arcing using this type of devices? And the key is exactly the frequency. So what happens is when we increase the frequency, number one, that electromuscular stimulation is not there anymore. And also, the electricity does not flow through our body, through the inside of our bodies. It flows outside of our bodies into Earth. Therefore, at higher frequencies, those currents are absolutely harmless to us. There's a very interesting experiment that's done every now and then by magicians. They actually go through chambers of arc generating devices and get stricken by a sort of lightning, artificially generated lightning. They go through them, they get hit a number of times as if nothing happens, as if it's actually as if it's commonplace and they're not hurt by them in any way, shape or form. So this is possible actually, and it's quite easily explained because these devices produce electrical arcs at high frequencies. So what happens is when you're hit by one of these arcs or one of this plasma, whatever you'd like to call it, although there's a lot of energy into these arcs, these are completely harmless to your body. So you can go through them, be stricken by this sort of lightning and get absolutely no harm to your body in any way, shape or form. And that is again because of the high frequency. So at high frequency, the electricity doesn't flow inside our bodies, it flows outside and is completely harmless to us. And also we have no electromuscular stimulation, therefore we're not going to, we cannot die of cardiac arrest due to that interference of the electricity with our hearts. So the frequency is extremely important and is something that is not touched by anyone. And the frequency that is used in most devices ranges from 50 kilohertz, 100 kilohertz, 300 kilohertz, 500 kilohertz, and so on. Now, the frequency is a very important point of these devices, and we'll explain why in a second. So what we have done so far, we've tried to make you understand why these devices work at relatively high frequencies compared to what we've got on the mains. And once again, they work at between 50 kilohertz and upwards. So the other thing, one of the reasons why we have made possible the variable frequency in our new plasma device is because the higher the frequency, the more superficial the ablation is going to be, keeping the voltage and the duration of the arc the same. So what we mean here is that, say for example, if I apply an arc which is the result of a voltage, say 100 volts at a frequency of 50 kilohertz for 1 second, And then I keep the voltage the same, I increase the frequency, and then I keep the arc on for the same amount of time, 1 second. What happens at higher frequency is that the ablation is going to be slightly shallower than the lower frequency. And this is an important point, because that brings us to the fact that the higher the frequency, the colder plasma becomes. Now, this is not to be confused by the cold plasma that we're able to generate using external gases like argon, which is a more effective way to have cold plasma. But this is also another advantage of having a variable frequency. So you can increase the frequency to have that sort of cold plasma effect, and a lower frequency the plasma is very, very hot, and it reaches and it does cause carbonization of the skin. So at the point of contact between the arc and the skin, the temperatures are very high, and this temperature once again diminishes as the frequency increases. That temperature decrease is not huge, but it does exist. And also another very important point to take into account is that as the frequency is increased, then the power associated to that electrical arc or plasma is increased as well. However, what happens is that the higher the frequency, the lower the effect on the skin, because again of that Faraday cage effect. The Faraday cage effect is when the current flows through the surface of your body or a surface of an object, and this is exactly what happens. So once again, the higher the frequency, the colder is plasma, the less you're going to feel it, the less pain you're going to feel during the treatment, and therefore this is one of the advantages that you get by using variable frequency and the capability of modulating that frequency. So what we do in our device, that frequency gets higher if you decrease the period, and you can actually set the device you can tell the device to do so, and it can get lower up to a certain extent, because we don't want to hit very low frequencies which cause some electromuscular stimulation. So we hope this has been a very interesting video for you, and we hope that you found a very important lessons in this video. If you have any question whatsoever, please feel free to get in touch with us, and we'll see you in the next video. Thank you very much for watching.